Friction is a force of nature. It occurs in nature everywhere whenever two objects come in contact. And its nature is to oppose any motion by creating a force opposite to the direction of movement. Friction can be part of the problem or part of the solution. Yet, we need friction. Without it, we would not be able to walk, sit in a chair, or climb stairs. Everything would just keep slipping around. If you want to push a book on a table, you have to apply force to move it. Heavier the book, more force is required. Then how do you define friction? Friction is defined as the force created when surfaces rub against each other. What is the reason? Surfaces are rough at microscopic level. These rough surfaces oppose the motion. What is the direction of the frictional force? Frictional force always acts in the opposite direction of the motion, and its goal is to oppose the motion of the object. What is the nature of friction? Well, friction can exist in three different forms. First one is static friction. As the name suggests, this is the frictional force that exists when the object is at rest. Comparatively, this force is higher than other form of frictional forces. That is why you need more force to make the object move from rest, and thereafter you need less force to keep the object moving. Next form of frictional force is kinetic friction. Sliding friction also opposes motion, but its intensity is slightly lesser than static friction. Next form of friction is rolling friction. Here the surfaces are not sliding, but one is rolling over other by having wheels. Due to less surface contact, this force is relatively less compared to other two forces. The amount of frictional force is experimentally observed to be proportional to nature of surface and the force normal to the surface. Mathematically, it is represented as frictional force equals nu times normal force. Note that normal force is always equal to the weight of the object. As an example, a boy pushing a stack of books on a table. The weight of the books equals weight of the object. Surface of the table opposes the weight of the book by producing force, that is normal its surface, and it is denoted as Fn. Frictional force opposes the motion and equals nu time Fn. The boy should exert a force more than nu time Fn to move the books. Let us solve some questions based on this theory and understand the concept better. In question 1, a 0.4 kilograms block is sitting on a surface. What is the coefficient of static friction between the block and surface when it takes 1.0 Newton of force before the block begins to move? Weight of the object equal to 0.4 kilograms. Multiply this by acceleration due to gravity g to convert this weight into units of Newton. G is approximated to 10 meter per second square. So weight equals 4 Newton. This is equal to normal force. Coefficient of friction is equal to frictional force divided by normal force, which is equal to 1 divided by 4 equals 0.25. So coefficient of friction is 0.25. In question number 2, the object is moving at constant velocity. Constant velocity means no acceleration. This means that applied force is just equal to frictional force and net force is 0. The object is moving, so it is kinetic friction. In question 3, weight of the object is given, frictional force is given, the object is moving with a constant velocity. So applied force is just enough to overcome frictional force. Coefficient of friction equals frictional force divided by weight of the object. We get nu equal to 0.2. Read question number 4 carefully. Applied force equals 45 Newton. Because wood block is moving at constant velocity, applied force equal to frictional force. Net force equal to applied force minus frictional force, which is equal to 0. Because net force is 0, acceleration is 0. In question 5, weight of the block is equal to 1.5 into g, which is equal to 15 Newton. For wood to wood, coefficient of friction is 0.25 from the table. So frictional force equals nu times weight of the block, which is equal to 3.75 Newton. In question 6, weight of the block is given in kg. Convert to Newton by multiplying acceleration due to gravity g. From the table, kinetic friction is 0.2. So frictional force equals 0.2 times weight of the object, which is equal to 3 Newton. In question 7, one surface is wood and other surface is brick. From the table, nu is 0.6. This value is to be taken for calculation. Frictional force is 90 Newton, whereas applied force is 120 Newton. Yes, the brick will accelerate. In question 8, weight of the brick equals 15 kilograms multiplied by g equals 150 Newton. For brick to wood surfaces, coefficient of kinetic friction is 0.45. So frictional force is 67.5 Newton. Net force equal to applied force minus frictional force, which is equal to 150. 67.5 is equal to 52.5 Newton. This net force produces acceleration of the object according to the equation force equals mass into acceleration. Acceleration is equal to net force divided by mass of the block is equal to 3.5 meter per second square. In question 9, mass of the object and coefficient of friction are given. Use the standard equation for frictional force and substitute the values. You will get frictional force equal to 583.2 Newton. In question 10, first calculate frictional force using coefficient of friction and mass of person, which is equal to 583.2 Newton. This backward frictional force causes deceleration of the person. Use the equation force equals mass into acceleration. So acceleration equal minus 7.2 meter per second square. The person takes 2 seconds to come to rest. Use the equation of linear motion v equals u plus a times t. You will get initial velocity equal to 14.4 meter per second. In question 11, the pulling force is not horizontal, but inclined by an angle 25 degrees. This inclined force has two components, one is horizontal and another is vertical. Horizontal component is the pulling force. The normal force is equal to weight of the object minus vertical component of inclined force. Rest of the calculations are straightforward. The remaining 5 questions are for practice. So we have understood that weight of the object, coefficient of friction and applied force are 3 important parameters in describing the motion under friction. We have reached end of the video. Thank you for watching.